All right, well, hello guys. Welcome back. We are ready to start a fun new lesson. Remember I told you guys that a big emphasis for this chapter is going to be working with algebra skills. That means factoring, that means quadratic formula, and other things that we'll go through, solving systems for sure. So I'm going to break this into two videos. This first one is going to be just factoring and quadratic formula, and then the second video is going to cover the new stuff, the circle properties that we're going to use this on. But let's do some factoring review. I've taught this lesson 2 times in the past, but third time's the charm. We're going to get this down. How would you multiply 64 times 35? Well, most of you were taught to do 64 times 35 like this. I call this stack and attack. And what you do is 5 times 4, and you say 5 times 4 is 20. You bring a 2 over here. And then what you don't realize here is you're doing 5 times 6, but a lot of people don't understand that's actually 5 times 60. And then when you go here, that is 30 times 4, and then finally you finish it with 60 times 30. This whole premise, while it gets you the answer, is not, I don't think, the best way to learn multiplication. A lot of people, once they hit Algebra 1, they don't do well in math classes. There's a lot of students that once we see this letter X show up and numbers go away, they don't pass another math class. That happens. There's a lot of students that really struggle, and I think a big part of it is they're taught things like this that doesn't mean anything to them. Yes, they can follow the steps and get an answer and maybe get it quickly, but this is not something you can do in your head, first off. Like, that's tough to do in your head, but it doesn't mean anything to a lot of them. If you had instead learned how to solve or how to multiply like this, it's the exact same work. You're still doing 60 times 30, 60 times 5, 30 times 4, and 4 times 5, but it looks way more like the algebra that we're used to. And if you can write this out, and then you can add all these things together. I would probably do those together first. This would be 140, so that'd be 440, and then plus 1800 would be 2240. I think this is faster and easier for a lot of people. It strengthens the math, but it also looks like real math. It's not, I don't know, I call this fake math. I don't know if it's fake math, but it's not math that's real intuitive. We don't really understand what's going on. And if you had been doing this since 3rd grade, you probably wouldn't have any issue transitioning over to something like x plus 10 times x plus 3. But as it is, this becomes a very difficult thing for people to process and do a good job on. So we've talked about it before, but you're going to distribute. That's going to be x times x. That's going to be plus 3x, plus 10x, and plus 30. And then the next thing we're going to do is combine like terms, and we know that it's x squared plus 13x plus 30. This and this are the exact same number. Like if you plug in a 1 here, it's the same thing as if you plug in a 1 here. It's the same answer, I promise, because it represents the same number. What I need you to learn how to do today, right now, is how to go straight to this. I don't want to see this middle line. Right? It's, at some point you got to move on. You got to be able to do things quicker and understand their patterns a little bit. So how would we do that? How do we get 13 from the original numbers? Well, as long as it's 1x and 1x, we're only talking about 1x. We're going to talk about others later. Well, we know that these two numbers end up adding to the middle number. 10 and 3 gave us 13. And then how did we get the 30? 10 and 3 multiplied to 30. So if we understand that pattern, we can do this a lot quicker. So for instance here, -2 and -6, those are the two numbers I'm working with. Well, if they combine to equal -8 and they multiply to positive 12. Here, x plus 11 and x minus 3, pause it, try to do it on your own. But what do we have? We have x squared, we would have 11 and -3 combine to equal 8, and they multiply to -33. So that's how you multiply. That's how you go forward. It's really hard to go backwards if you don't know how to go forwards. So when we get to a question like this has already been multiplied in essence. We know that the numbers have to multiply to 11, and they have to add to 11 and multiply to 24. How many different combinations give you 11? Well, could that be 10 and 1? Could that be 8 and 3? Could that be 4 and 7? Could that be 12 and -1? 14 and negative. Like the list is forever. We don't want to go down that giant list. That list could take a long time to find the numbers that work. But what we do instead is we go to the 24. That's a finite list. What numbers multiply to 24 but add to 11? And this add right here, this plus sign, is huge. If that was a minus sign, they would need to subtract. And so you go down the list, 1 and 24, those add to 25. 2 and 12, those add to 14. And then 3 and 8, those are the numbers that add to 11. And then you think for a second, okay, it's actually positive 11. So what do I do with 3 and 8 to get a positive 11? Well, I make them both pluses, and there's my factors. Guys, I know lots of teachers teach boxes, they teach X's, they teach all kinds of graphic organizers, but that's just not going to cut it anymore. We got to be better, we got to be faster. It's like back in kindergarten, you counted the stars. You had 1, 2 stars, and then you had 3 stars, and then you counted 1, 2, 3, 4, 5, and that's how you did 2 plus 3 equals 5. At some point, you had to stop drawing the stars. We can't do that every time we have to do 2 plus 3. We can't do graphic organizers every time we have to factor an equation. I suggest it would be awesome if you hit pause and try to do the rest of these, but I'm going to go through them pretty quickly. What factors of 14 subtract to equal 5? That's going to be 7 and 2. Well, how do we get negative 5 from that? By subtracting 7 and adding 2. That would give me negative 5. How about the factors of 35 that add to 12? 35, they need to add to 12. That is going to be 7 and 5. So 7 and 2 up there, 7 and 5 here. They need to add to 12. Well, how do I get negative 12 out of 7 and 5? They need to both be subtraction. And we're done there. And you can check, go back the other way. What is negative 7 and negative 5? Well, they combine to make negative 12, and they multiply to make positive 35. They should always go back to where you came from. All right, this one's a tricky one for a lot of people. There's two options. Is it x minus 6, x plus 1? That's one choice. Or x minus 3, x minus 2. It's one of those. This one has a high miss rate because we have two ways to make 5. They both make negative 5, right? Negative 6 and 1, that's negative 5. Negative 3 and negative 2, that's negative 5. They both make negative 5. But that's only one requirement. The other requirement is plus 6. And this is the one that gives you plus 6. This top one does not get the job done. So one way to avoid that issue is it had to be factors of 6 that add to equal 5. Well, do 6 and 1 add to equal 5? No, they subtract to equal 5. So it had to be 3 and 2. 3 and 2 add to 5 and multiply to 6. Those are the numbers that we needed to use. Here the leading coefficient is 5, but notice everything's a multiple of 5. So I'm going to pull the 5 out. Remember, we're factoring, we're not solving. I'm going to pull the 5 out, and that's going to be x squared plus 8x plus 15. And now I'm going to treat this section as if it's one of these. So what factors of 15 add up to 8? And that's going to be 5 and 3. And this would be our answer here. All right. One quick note that I want you guys to understand is, we're going to have to solve. We're going to have to get solutions. What would be the solutions to, this one? Negative 7 would become positive 7. Negative 5 would become positive 5. A lot of people are like, it's just the opposite. It's just the opposite. And you're right. You are doing the opposite. But I want you to understand it a little bit more than that. When we're solving it, we're setting it equal to 0, right? We're trying to figure out what makes it 0. So you plug in 7. Well, what is 7 minus 7? That's 0. That's why we picked 7. But your real question should be, when you look at this, is not what's the opposite. That's not a good question. It's what makes this 0? Well, the answer is positive 7. And why do we care about that? Well, what is 7 minus 7? 0. What is 7 minus 5? It doesn't matter. You guys know who The Rock is. It doesn't matter what it is. Because what is 0 times any number I put there? It's going to be 0. So if we can make the number 0, then the whole thing's going to be 0. How about over here? What makes this one 0? We plug in a 5. This would become 0. Plug in a 5. This one's negative 2, but it doesn't actually matter. 0 times anything is 0. So there's two numbers that make the whole thing 0, 5 and 7. What if our factor was 2x plus 10? or let's do like a plus 11. What if this was our factor? What makes that 0? Pretend it's equal to 0. How would you solve it? You would subtract 11 and divide by 2. So you're undoing this. Yes, you're undoing it. What makes it 0? How do you figure that out? By undoing it. Negative 11 divided by 2 would undo that. Okay, that's just a little sidebar. Quadratic formula we got to know, right? X equals negative b plus or minus the square root of b squared minus 4ac over 2a. We got to know the quadratic formula. This can be tricky. This can be a pain point for a lot of people for a long time. So here I have two extreme examples. This is about as easy as they get. This is about as hard as they get. And you will have to do this next year in Algebra 2. You have to know how to do this without a calculator. So I'm going to do both types of questions here. I'm going to do it with a calculator and without a calculator. And I want you to practice doing both. First, we're going to do it without a calculator. Well, look at this equation. What do you think is the best part to do first? Well, if you said this part, you are correct. That is b squared minus 4ac. And we need to note that this is ax squared plus bx plus c. So for this question, a equals 2, b equals 7, and c equals negative 10. So b squared would be 7 squared minus 4 times a times c. So we're doing the b squared minus 4ac first. That's the easiest thing to do first. That'd be 49 plus 80 is 129. But don't forget it's the square root of that. So when we do the whole thing, it's going to be negative 7, negative b, plus or minus the square root of the inside we just said is 129 all over 2a would be 2 times 2, which is 4. And there's our answer. That's as easy as that gets. Why is that so easy? Because the number inside the square root here could not be broken down. It was positive. There's nothing we could do with it. That was the easiest case that we can have. Okay? Putting it into the calculator. Let's say we typed in the calculator. And guys, if you have the calculator, there's no reason not to use it. But you won't have the calculator all the time. And I guarantee next year in Algebra 2, there will be test questions without a calculator where you have to be able to do this. And they expect you to know how to do this. But you would do negative b plus or minus the square root of b squared minus 4 times a times c. All divided by 2 times a. Practice typing that in. I'm going to type it into my calculator right now. And you can kind of see it here. We're going to start with the fraction key. And we're going to type in the top, which was negative 7. We can't do plus or minus, so we're going to do just plus. Negative 7 plus the square root of 7 squared minus 4 times, I think a was 2, and then b was negative 10, if I remember correctly. Divided by 2 times 2. That is negative b plus or minus, we just did the plus, b squared minus 4ac all over 2a. We type it in there. And boom, that's what we got. So you need to know how to type it in, but you need to know how to do it by hand as well. So it's really important to me that we can do both things. All right, so that was as easy as they get. This one is about as hard as they get. And there's a lot of stumbling points or stumbling blocks for people here. And I'm going to try to bring those up as we go. First issue is it needs to be equal to 0. So we need to subtract 3x from both sides. We need to subtract 7 from both sides. And we'll have 3x squared minus 2x minus 9 equals 0. And now we're going to do quadratic formula. So what do I do first? I do the b squared minus 4ac first. So I'm going to do it off to the side. B squared minus 4ac would be negative 2 squared minus 4 times a times c. That would be 4. That would be 12 times 8. That'd be plus 108, which is 112. But we have to take the square root of that. This gets tough. Your Algebra 2 teachers expect you to be able to take a square root, guys. So what I told you guys in the past is factor out perfect squares. I don't know the biggest perfect square, but actually I do, but when I first did it, I didn't. So let's just do it how I did it when I did it by myself. I took out a 4, and I knew that 4 times 25 was 100, and then I have another 12. So I know it's 4 times 28. Well, another perfect square goes into 28. So I broke down the 28, and what I'm left with is root 4 times root 4 times 7, right? This is, if I wrote it out, it'd be root 4, root 7. Well, what is root 4 times root 4? That's just 4 root 7. What that means, little sidebar, is what we could have done from the beginning is we could have done root 16 times root 7, right? That's the same thing. That's the same thing. But that equals 4 root 7. So first big stumbling block is that the radical can be simplified. And a lot of students don't remember how to do that. That's a hard process, especially like the number 112. That's not super easy. So you have to really know your stuff, how to simplify radicals in order to be able to do that. Okay, so then let's do the rest of the formula. Negative b is would be positive 2 plus or minus the square root. Oh, sorry, we actually already did that. That's going to be 4 root 7 plus or minus 4 root 7 all over 2 times 3 would be 6. So here's another big stumbling block is that this can be reduced. Look at the 2, the 4, and the 6. Isn't there a GCF for all three of those? Yes, so I can reduce that to 1 plus or minus 2 root 7 all over 3. So that's the final answer. Now, I do want to practice typing this into the calculator. So we've already seen 2 of the big stumbling blocks. One of them, we had to simplify root 112. That's hard for everybody. We got to practice and get really good at that. 2 is it simplified, the fraction reduced. One thing I will note is that what if this was a 5 in front? Then we would just be done. You cannot reduce just the 2 and the 6, not unless you pull the fraction apart. As a single fraction, it would be totally done. Either you reduce all the numbers or none of the numbers, but you can't do a mix and a match. All right, so I'm going to type this into my calculator off screen because I don't remember the numbers that well, but it was negative 2, so it'd be positive 2 plus or minus the square root of negative 2 squared minus 4 times 3 times negative 9 all over 2 times 3. And so what I want you to see here, and I will show you now that I've typed it in, is a lot of people mess this up. Where do you think they mess it up? Look real close. For most people, they mess it up right here. So this is stumbling block number 3, is when you use the calculator, people type it in wrong. When they go here, if I take these parentheses off, it's a completely different number, guys. It's completely different, and that is a crucial error that a lot of people do. You don't want to square 2 and then make it negative. You want to square the number negative 2. Those are completely different things. So make sure you type it into the calculator right. All right, guys. So that's factoring quadratic formula. It's really important that you can do all that. My next video I'm going to start in just a moment is about segments of circles.